ocean world of K2-18b. Is this where we find alien life? Part 1. A Cosmic Invitation. Welcome, mystery seekers, to Extraterrestrial Mystery. Today we're embarking on a journey that will take us far beyond the stars, to a world that could rewrite everything we know about life in the universe. Close your eyes for a moment and imagine standing on the edge of an endless ocean. Not on Earth, but on a distant planet, 124 light-years away. The sky glows with the faint red light of an alien star. The air hums with strange vibrations. And beneath your feet, a vast, shimmering sea stretches to the horizon, whispering secrets of a world unknown. This is K2-18b, a planet that's captured the imagination of scientists and dreamers alike. Is it a lifeless water world, or could it be home to alien life, perhaps even intelligent beings watching us from across the cosmos? For the next 2 hours, we're diving deep into the enigma of K2-18b. We'll uncover the groundbreaking discoveries that have made this planet a cosmic superstar, explore the science that hints at life, and dare to imagine what creatures might swim in its alien oceans. From telescopes peering into the void to wild theories about interstellar visitors, this is a story that will make you question, are we truly alone? So grab a seat, turn down the lights, and let's blast off into the unknown. Let's start with the basics. K2-18b isn't just another dot in the sky, it's a potential game changer. Discovered in 2015 by NASA's Kepler Space Telescope, this exoplanet stood out among over 1,200 others. Why? Because it orbits in the habitable zone of its star, that sweet spot where temperatures are just right for liquid water, the key ingredient for life as we know it. Picture a world 2.5 times larger than Earth, 9 times heavier, and possibly covered by an ocean so vast it makes our Pacific look like a puddle. Scientists call it a super-Earth, but some dreamers see it as a cosmic aquarium, a planet-sized droplet of water floating in the void. What makes K2-18b so special? It's not just its size or its orbit, it's the tantalizing clues that suggest something might be alive out there. In 2019, the Hubble Space Telescope detected water vapor in its atmosphere, a discovery that sent shockwaves through the scientific world. Water is the foundation of life, and finding it on a distant planet was like spotting a cosmic welcome sign. But the real bombshell dropped in 2023 when the James Webb Space Telescope, humanity's most powerful eye in the sky, found something even more incredible, a chemical called dimethyl sulfide, or DMS. On Earth, DMS is produced only by living organisms like the algae that give our oceans their salty, briny scent. And get this, K2-18b has DMS levels 1,000 times higher than Earth's. Scientists estimate a 99.7% chance that this is a sign of life. Are we on the verge of discovering aliens, or is the universe playing a cosmic prank? This journey is more than just one planet. It's about humanity's quest to answer the ultimate question, are we alone? K2-18b is our guide, a beacon in the vastness of space that challenges everything we believe. Over the next 9 parts, we'll unravel its secrets, from the telescopes that found it to the creatures that might call it home. We'll also explore other bizarre worlds and ask what it means to find life beyond Earth. So let's begin where it all started, with a telescope that changed the game. Part 2. The Kepler Discovery. Welcome back, seekers. We've set our sights on K2-18b, a water world that might hold the key to alien life. But how did we find this cosmic gem? And what makes it so different from the other thousands of exoplanets out there? Let's rewind to 2015 and meet the hero of this story, the Kepler Space Telescope. Launched in 2009, Kepler was like a galactic explorer, scanning the heavens for planets beyond our solar system. Its mission was simple but mind-boggling. Stare at a patch of sky, watch for tiny dips in starlight, and use those dips to spot planets passing in front of their stars. Over its lifetime, Kepler discovered over 2,600 exoplanets, but K2-18b was a standout. Why? Because it orbits a red dwarf star, a smaller, cooler cousin of our Sun, at just the right distance to support liquid water. This region, called the habitable zone, is the cosmic Goldilocks zone. Not too hot, not too cold, but just right for life. K2-18b isn't an ordinary planet. It's a super-Earth, with a diameter 2.5 times ours and a mass 9 times greater. That means it's a heavyweight, with gravity that would make you feel like you're carrying a backpack full of bricks. But the real kicker, scientists believe it could be a water world, covered by an ocean dozens of miles deep with no land in sight. Imagine a planet where every horizon is water, where waves crash under a reddish sky, and where the very air might carry the scent of life. It's a place that feels both alien and strangely familiar, like Earth's wildest dreams brought to life. To confirm K2-18b's potential, other telescopes joined the hunt. In 2017, the Spitzer Space Telescope and the HARP spectrograph in Chile pinned down its orbit and characteristics. They found that K2-18b receives about the same amount of heat and light as Earth, making it a cozy candidate for life. Another clue? Its atmosphere lacks ammonia, a chemical that would dissolve in water. This suggests K2-18b's surface is one giant ocean, swallowing up ammonia like a sponge. The picture was starting to form, a planet unlike anything we'd seen, a world of water under a distant star. But Kepler and his friends only gave us the basics. To really understand K2-18b, we needed to peer into its atmosphere, and that's where the Hubble Space Telescope came in. In 2019, Hubble made history by detecting water vapor in K2-18b's atmosphere. It was a moment that made scientists cheer and dreamers gasp. Water vapor means clouds, maybe rain, maybe oceans. It means a planet that could support life as we know it. Suddenly, K2-18b wasn't just a dot in the sky. It was a candidate for the most profound discovery in human history. This discovery set the stage for the next big leap, one that would push K2-18b into the spotlight and spark debates that still rage today. What was in that atmosphere, and could it mean life? Let's dive deeper.
Part 3. The Scent of Life. We're back, mystery seekers, and things are about to get wild. K2-18b is already a star in the cosmic lineup, with its massive oceans and habitable orbit. But in 2023, a discovery shook the world and made us wonder, have we found alien life? Let's talk about the chemical that's got everyone buzzing, dimethyl sulfide, or DMS, and why it's the biggest clue yet that K2-18b might be teeming with life. First, let's rewind to 2019, when the Hubble Space Telescope spotted water vapor in K2-18b's atmosphere. That was huge. Water is the foundation of life, the universal solvent that makes biology possible. But water alone isn't enough. To find life, we need biosignatures, chemicals that scream, "Something's alive here." Enter the James Webb Space Telescope, or JWST, launched in 2021 as humanity's most advanced cosmic detective. In 2023, JWST turned its golden mirror toward K2-18b and found something jaw-dropping: DMS. So what's DMS? On Earth, it's a compound produced only by living organisms, like the phytoplankton and algae that thrive in our oceans. Ever smelled that salty, briny tang when you stand by the sea? That's DMS, the signature of life in our waters. Now, imagine that scent amplified 1,000 times. That's what JWST detected on K2-18b. Scientists were stunned. Could this mean alien algae or something even stranger is churning out DMS in K2-18b's oceans? The numbers are staggering. Researchers estimate a 99.7% chance that DMS on K2-18b is a sign of life. That's not 100%, but it's close enough to make your heart race. Picture this: a planet 124 light-years away, covered in water, with an atmosphere carrying the chemical fingerprint of living creatures. It's like the universe is whispering, "You're not alone." But before we pop the champagne, there's a catch. DMS could be produced by non-biological processes, chemical reactions we haven't fully explored. The jury's still out, and scientists are racing to confirm what JWST saw. This discovery didn't happen in a vacuum. It built on years of work by telescopes like Spitzer and HARPS, which confirmed K2-18b's place in the habitable zone. They also found clues, like the absence of ammonia, that point to a water-dominated world. But JWST took it to the next level, giving us a glimpse of an atmosphere that might be alive with activity. The lead researcher, Professor Niku Madhusudan, believes we're on the cusp of a breakthrough. He predicts that within 1 to 2 years, by 2025 or 2026, JWST will give us definitive answers. Will DMS prove to be the smoking gun of alien life, or just a cosmic red herring? This is where the mystery deepens. Not everyone agrees on what K2-18b is. Some scientists think it's a vibrant ocean world, while others see it as something else entirely. Let's explore the debate that's dividing the experts. Part 4. Ocean world or gas giant? Welcome back, Seekers. We're riding the wave of excitement over K2-18b's DMS discovery, but not everyone is on board with the idea of an alien ocean teeming with life. There's a heated debate in the scientific world about what K2-18b really is, and it's splitting experts into two camps. Is it a water world ripe for life, or something far less hospitable? Let's dive into the controversy and see what's at stake. On one side, we have Professor Niku Madhusudan and his team, who envision K2-18b as a Hycean world, a term they coined for planets with hydrogen-rich atmospheres and vast oceans. Picture a planet covered by water, with waves crashing under a hazy reddish sky. The evidence is compelling. Water vapor in the atmosphere, no ammonia, which would dissolve in water, and now DMS, a potential biosignature. Madhusudan argues that K2-18b is a super-Earth with a solid core surrounded by an ocean that could be dozens of miles deep. This ocean, he says, could be home to life, maybe microbes, maybe something more advanced. His team is betting on JWST to confirm this vision, predicting that by 2026 we'll know if K2-18b is a living world. But not so fast. On the other side, scientists like Dr. Nicholas Vaughan from the La Silla Advanced Research Center have a different theory. They think K2-18b might be a mini Neptune, a small gas giant with a thick atmosphere of hydrogen and helium, but no solid surface. Imagine a planet like a giant, fluffy ball of gas where you'd sink forever without ever touching ground. In this view, K2-18b's atmosphere might contain water vapor, but it's not a sign of oceans, just moisture trapped in a gaseous soup. The DMS? It could be a chemical fluke produced by reactions in the atmosphere rather than life. The Vaughan camp argues that K2-18b's size and mass make it more like a scaled-down Neptune than a beefed-up Earth. This debate isn't just academic, it's about the very nature of life in the universe. If K2-18b is a Hycean world, it opens the door to a new class of habitable planets we've barely considered. If it's a mini Neptune, it's a reminder of how tricky it is to find Earth-like worlds. Both sides agree on one thing: JWST is our best hope for answers. Its next observations could settle the score, revealing whether K2-18b's DMS is a biological beacon or just a cosmic false alarm. This uncertainty is what makes science so thrilling. Every discovery raises new questions, and K2-18b is no exception. Is it a world of water, alive with alien creatures, or a gas giant mocking our hopes? While we wait for answers, let's let our imaginations run wild and ask, if life does exist on K2-18b, what could it look like? Part 5. Life in the Alien Ocean. We're deep in the mystery now, Seekers, and it's time to dream big. K2-18b's potential as an ocean world has us wondering, if life exists there, what could it be like? From tiny microbes to giant sea monsters, let's explore the possibilities of an alien ecosystem 124 light-years away. Buckle up, this is where science meets science fiction. Let's start small. If K2-18b has life, it might begin with microbes, similar to the extremophiles that thrive in Earth's harshest environments. Think of the bacteria living near hydrothermal vents in our oceans, where temperatures soar past 100 degrees centigrade. These microbes don't need sunlight. They get energy from chemical reactions, like oxidizing hydrogen sulfide. On K2-18b, with its deep oceans and hydrogen-rich atmosphere, similar microbes could be churning out DMS, creating the chemical signal JWST detected. Picture billions of tiny organisms, invisible to the eye, dancing in the dark waters of an alien sea, their chemistry leaving a cosmic fingerprint. But what if life has evolved further? K2-18b's environment is extreme. Gravity 9 times Earth's, an ocean 15 miles deep with pressures of 2,400 atmospheres, and a dim red star providing scant light. Any creatures here would need to be tough. Imagine jellyfish-like beings, floating gracefully in the currents, their bodies glowing with bioluminescence to light up the murky depths. The low density of hydrogen atmosphere could allow them to grow massive, dwarfing anything in Earth's oceans. Some might have polymer-based exoskeletons, like natural armor, to withstand the crushing pressure. Picture a creature the size of a whale, its shimmering shell catching the faint red light, gliding through the water like a living spaceship. Now, let's push the boundaries. What if K2-18b has complex life, like the octopuses of Earth, but adapted to an alien world? These creatures might have multiple limbs, each tipped with sensors to detect vibrations or heat, since light barely penetrates the deep ocean. Their bodies could be flexible, yet reinforced, built to survive pressures that would crush a submarine. And if evolution has taken them further, they might form schools or colonies, communicating through pulses of light or chemical signals. Imagine a glowing underwater city, not built, but grown, where these beings share knowledge in ways we can't comprehend. The ocean's depth and chemistry could support a food web unlike anything on Earth. At the base, microbes feed on chemical energy. Mid-level creatures, like our jellyfish analogs, graze on these microbes or filter nutrients from the water. At the top, apex predators, think giant bioluminescent squids, hunt with precision, their bodies adapted to move swiftly despite the pressure. This ecosystem would be a symphony of life, thriving in conditions that seem impossible to us. But here's the big question. Could K2-18b have intelligent life? We'll explore that next, along with what it might mean for humanity.
Part 7. Humanity's Cosmic Quest. We're venturing deeper, Seekers, and K2-18b is more than a planet. It's a mirror reflecting our deepest hopes and fears. The possibility of life there challenges everything we believe about our place in the cosmos. Why are we so obsessed with finding aliens, and what would it mean if we did? Let's explore the human side of this cosmic quest. The search for life on K2-18b isn't just about science, it's about identity. For centuries, we've looked to the stars and asked, are we alone? It's a question that drives philosophers, poets, and scientists alike. Finding life, even simple microbes, would be a seismic shift. It would mean the universe is alive, teeming with possibilities. We no longer be a lonely speck in the void, but part of a cosmic community, connected by the shared spark of life. K2-18b is a perfect test case. Its water, DMS, and habitable orbit make it a beacon of hope. But the search is also about self-discovery. Every exoplanet we study teaches us about Earth, how rare it is, how fragile. K2-18b's oceans remind us of our own, urging us to protect them. Its alien chemistry pushes us to rethink what life can be. And its distance, 124 light-years, humbles us, showing how small we are in the grand tapestry of the universe. The scientists behind K2-18b's discoveries are modern explorers, hunched over data from JWST, chasing a dream. People like Niku Madhusudan spend years analyzing spectra, hoping to catch a glimpse of life. Their work is a testament to human curiosity, the same impulse that took us from caves to spacecraft. Each discovery, from water vapor to DMS, is a step toward answering that ancient question: is there anyone else out there? But finding life would also raise new questions. If K2-18b has microbes, what's next? Do we search for intelligence? If we find a civilization, do we reach out or stay silent? The risks are real. Hostile aliens could spell doom, as countless sci-fi stories warn. But the rewards, a shared future with other worlds, could transform humanity. Imagine a day when we look at the stars not with wonder, but with connection, knowing we're part of something bigger. K2-18b isn't our only hope. Let's zoom out and explore other worlds that might hold the key to life. Part 8. A galaxy of possibilities. Welcome back, Seekers. K2-18b has us dreaming of alien oceans, but it's just one star in a galaxy full of possibilities. The universe is brimming with exoplanets, each a potential home for life or a reminder of how strange reality can be. Let's take a cosmic tour and see what else is out there. First up, T-Garden b, just 12.5 light-years away, a cosmic neighbor. This planet is 60% Earth-like, with temperatures between 0 and 50 degrees Celsius and potential for liquid water. But there's a catch. It might be tidally locked, with one side in eternal day and the other in endless night. Life could thrive in the twilight zone, a narrow band where light and dark meet, like a cosmic Eden. It's a world that feels close, yet maddeningly out of reach. Then there's TOY-700d, 101 light-years away, with a stable climate and a surface temperature around -4 degrees Celsius. It's a solid candidate for habitability, orbiting a star that's calm and steady. Gliese 581d, only 20 light-years away, has an Earth-like mass and sits in its star's habitable zone, making it a tantalizing target. These planets are like K2-18b's cousins, each offering a glimpse of what life might look like beyond our world. But the universe isn't all cozy Earth twins. Some exoplanets are straight out of a surrealist painting. Take J1407b with rings 200 times larger than Saturn's, a cosmic jewel that dazzles the imagination. Or WASP-76b, where temperatures are so high that iron rain falls from the sky, a hellscape of molten metal. PSR J17191438b might be a diamond planet, its surface glittering under the glow of a neutron star. WASP-107b is so light it's nicknamed Cosmic Cotton Candy, a fluffy giant that defies physics. And GJ1214b, another water world, has water in a supercritical state, neither liquid nor gas, like an ocean from a fever dream. These worlds remind us that the universe is a place of infinite variety. K2-18b's oceans might be home to life, but other planets challenge us to rethink what life could be. A diamond planet with crystalline creatures, a gas giant with floating jellyfish. The possibilities are endless, and each discovery pushes our imagination further. But why do we keep searching, even when the odds seem stacked against us? Let's explore the heart of this quest.
Part 9. The Drive to Discover. We're nearing the end, Seekers, and K2-18b has shown us a universe full of wonder and mystery. But why are we so driven to find life out there? What fuels this relentless search, and what would finding aliens mean for humanity? Let's dive into the heart of our cosmic obsession. The quest for alien life is about more than science. It's about meaning. Since the dawn of time, humans have looked to the stars for answers. Ancient myths spoke of gods in the sky. Today, we search for neighbors. Finding life on K2-18b, even a single microbe, would be a turning point. It would mean the universe isn't a barren void, but a garden of life, with Earth as just one flower. We'd feel connected, part of a cosmic story that stretches across light years. This search also teaches us about ourselves. Studying K2-18b's oceans makes us value Earth's. Imagining alien biology expands our definition of life. And grappling with the distance, 124 light-years, forces us to confront our limits. Every exoplanet is a lesson, a chance to grow wiser, bolder, and more curious. The scientists driving this quest are heroes of the mind. Picture them in labs, poring over JWST data, chasing a signal that could change history. Their work is slow, meticulous, but fueled by a spark of wonder. When Niku Madhusudan saw DMS in K2-18b's atmosphere, he didn't just see a chemical. He saw a possibility, a chance to answer the question that haunts us all. But the search isn't without risks. If we find intelligent life, we face choices. Do we send a message, risking exposure to a hostile species? Or do we stay silent, preserving our safety, but missing a chance for connection? K2-18b, with its DMS and oceans, brings these questions closer than ever. It's a reminder that discovery is a double-edged sword, offering hope and danger in equal measure. As we near our conclusion, let's ask, what if we do find life on K2-18b? How would it change us? Part 10. A New Dawn. We've reached the final chapter, Mystery Seekers, and K2-18b has taken us on a journey through science, imagination, and the human spirit. From water vapor to DMS, from ocean worlds to cosmic cotton candy, this planet has challenged us to dream bigger and question deeper. So what does it all mean, and where do we go from here? If we confirm life on K2-18b, it will be a moment that echoes through history. A single microbe would prove that life is common, that the universe is alive with possibility. An intelligent civilization would redefine our place in the cosmos, turning science fiction into reality. We'd look at the stars with new eyes, not just with wonder, but with kinship. Imagine a night sky that feels like home, because we know we're not alone. But even if K2-18b turns out to be lifeless, the search is worth it. Every planet we study, every signal we chase, brings us closer to understanding the universe. K2-18b's DMS might be a false alarm, but it's already pushed us to build better telescopes, ask better questions, and dream better dreams. The James Webb Space Telescope is just the beginning. Future missions could take us closer to the truth. For now, K2-18b remains a mystery, a world of water and whispers. Somewhere in its oceans, microbes might be stirring, or creatures might be glowing in the dark. Maybe, just maybe, an intelligent being is looking up at their red sky, wondering if we exist. That thought, that shared curiosity, is what binds us to the cosmos. So here's my challenge to you, Seekers. Share your thoughts in the comments. Do you think K2-18b has life? Microbes, monsters, or minds? Would you want to meet its inhabitants, or keep our distance? And what other exoplanets do you want us to explore? Drop your ideas below. We're building a community of cosmic dreamers. If you love this journey, hit that like button and subscribe to Extraterrestrial Mystery. Next week, we're chasing another cosmic enigma, so stay tuned. Until then, keep looking up, keep wondering, and never stop asking, what's out there?
The universe is waiting, and K2-18b might just be the first page in a story that changes everything.